In this video, we're going to look at simplifying and some ways to solve rational expressions. And when we're instructed to simplify a rational function, we're trying to see if we can't reduce the problem and find some common factors between the numerator and denominator to make it appear a little bit more simple. And I'm going to kind of skip around on this page here. And I want to start with this one here, number 2. And so through the process of simplifying, usually you just want to try and factor. So I factor my numerator, and that's going to make 7 times n minus 2 divided by n minus 2. And I try to look and see if anything cancels out. And in order to cancel something out, it has to be a common factor. And the n minus 2's are common factors. So I can cancel them out, which means that my simplified version of this problem is 7. All right, so number 2 simplified all the way down to 7. Let's go look at a different one. Number 4 looks a lot more complicated here. So I want to simplify this. Here's what we can't do, is I can't say, oh, I can cancel out the b squareds and cancel out the b's, and then just say 12 plus 20 is 32 divided by negative 19. I can't do that. It doesn't work that way. I need to factor the problem here. So I want to completely factor. All right, so my numerator would factor to b plus 2 times b plus 10. And my denominator here would be b minus 7 and b plus 2. All right, so I'm looking for what can cancel. And I see I can cancel out the b plus 2's. I have a b plus 2 as a common factor of both my numerator and denominator, so they'll cancel out. And what's left after I do that would be b plus 10 divided by b minus 7. All right, so there's my simplified form. Let's go find another one. Let's do this one. Number 6. All right, so numerator here, I'm going to factor. I have to take out the GCF. The greatest common factor in the numerator would be 3p squared. So I'm going to pull out 3p squared. When I do that, that's going to leave me with p plus 1. My denominator here, I have a common factor. I can take out a GCF to make this problem simpler. I have a common factor of 8p. And when I pull out an 8p, my denominator becomes p squared plus 3p plus 2. And so I'm going to work to factor that. So that would make p plus 1 times p plus 2. And I look and say, well, what can I cancel out here? I have a common factor of p plus 1. They'll cancel. And then I have p squared divided by p. So I can cancel out a p here, and I cancel that 2 out, and that 2 becomes a 1. So my simplified form becomes 3p, that's what's left in the numerator, divided by 8 times p plus 2. I don't have to distribute that 8 back in. I can leave it just like that in factored form. All right, let's go to another one. Let's see, number 8. So now we're going to go on to multiplying and dividing. And I want to perform the operation. I want to simplify. Now, when we're multiplying rational functions, I use the same process as if I'm multiplying fractions. You multiply fractions by multiplying straight across. Numerator times numerator, denominator times denominator. However, I don't want to jump right into the multiplying process because I would much prefer trying to reduce this problem as much as I could. And so I'm going to try to go through the process of factoring. Now, I start trying to factor my numerator. So that would factor to v minus 5 times v plus 3 All right, and then I want to look at this denominator. Well, a lot of people have a hard time factoring when I have a negative squared term. So if I pull the negative out, and then look at what I'm working with after that. I would have negative, let's see, multiply to make 12 and be negative 8, so that'd be v minus 6 times v minus 2. So I did the fraction on the left, and now I want to factor the fraction on the right. So that I can pull out a 6 in the numerator. So it'd be 6 times v minus 2 divided by, well, that would make v minus 5 times v plus 3. Now, when I multiply fractions, I multiply straight across. So I'm multiplying top to top, bottom to bottom, and I put all that together, and my problem becomes I have v minus 5 times v plus 3 times 6 times v minus 2 over negative v minus 6 times v minus 2 times v minus 5 times v plus 3. So I did the multiplication part. Now I want to see if anything can cancel out and reduce my answer. Well, I start looking through. I see v minus 5s both in the top and the bottom, and they're common factors because everything is multiplying. The v plus 3s will cancel. The v minus 2s will cancel. And so there's not much left here. My simplified form, after I did the multiplication, all that's left in the numerator is 6. And my denominator is negative 1 times v minus 6. And that's as far as I can go. Simplified form. All right, let's look at a division problem, how that changes what we do. Now, when I'm doing a division problem, I like to rewrite it as multiplication right out of the gate. And when we are dividing fractions, you do skip, change, flip. So the first fraction stays exactly the way it is. So 2a minus 6 divided by a squared plus 12a minus 27. And I'm going to change that that division into multiplication. And then I have to flip that second fraction. So it would be a minus 9 on top over a squared plus a minus 72. So I changed it to be multiplication. So keep, change, flip, or skip, change, flip. And now we do just like what we did for the previous problem. I want to, before I jump in and multiplying everything out, I want to see if I can't reduce this. So I'm going to factor, pull out the GCF of 2 in the numerator on the left. So it'll be 2 times a minus 3 over top of, now I got to factor this denominator. And so people struggle with that leading term being negative. So if I pulled the negative out, it would be negative 1 times a squared minus 12a plus 27. And so that would factor to negative 1 times a minus 9 times a minus 3. So I factored my fraction on the left, and I want to factor my fraction here on the right. So I have a minus 9 over, now a squared plus a minus 72. That would be a plus 9 times a minus 8. Okay, well, from here, if I want to, I could go ahead and cancel. I could cancel these a minus 3s right here. I can cancel them out right out of the gate. Now, I can't really cancel anything else within the individual fractions themselves. I would go through and do the multiplication. When we multiply fractions, remember, we multiply straight across. So I would have 2 times a minus 9 over negative 1 times a minus 9 times a plus 9 times a minus 8. And I could cancel some things out here. I could cancel out the a minus 9s. And that's all that cancels. So my simplified form here would be equal to 2 divided by negative a plus 9 times a minus 8. All right, so that's multiplication and division of rational functions. Now let's look at some adding and subtracting. All right, so we'll look here at number 13. So I want to add and subtract, or I want to add these two rational functions. Now, in order to add rational functions, I have to apply the same rules that I do if I was adding or subtracting two fractions. I must have common denominators. So the common denominator here is going to be the product of x minus 4 and x minus 5. So I'm going to rewrite my fraction. So I have 5 times x minus 4. Now, in order to make it have the same denominator as the second fraction, I'm going to have to multiply both the top and the bottom by x minus 5. All right, and then I'm going to keep writing my problem, and I'm going to write my second fraction. So it'll be 4 over x minus 5. Now, the 4 already has the denominator of x minus 5, but it needs to have the factor of x minus 4, so that way they have like denominators. So it needs to get multiplied, both the numerator and the denominator, by x minus 4. Now, I'm going to multiply out the numerators. So my fraction here on the left-hand side is going to become 5x minus 25 over, now I'm not going to FOIL out the denominators. I'm going to leave it as the product of x minus 4 times x minus 5. And the reason why is we want to leave it as in factored form in case we get lucky and after we do all this, we can cancel something out. So now I have plus, and now I'm going to do the same thing for the fraction on the right. So I'm going to distribute the 4. That makes 4x minus 16 over top of x minus 5 times x minus 4. Now, the fractions have the same denominator, so now I can write them as one fraction. So my next line is going to become, so I have 5x minus 25 plus 4x minus 16 all over x minus 4 times x minus 5. Now we continue to work from here. So I do this, I end up with 9x, and then negative 25 minus 16 is negative 41 over x minus 4 times x minus 5. And there's no GCF in my numerator, so here is my final answer. So in order to add and subtract rational functions, I have to create common denominators. And usually the common denominator is going to be the product of the two denominators in the fractions involved. All right, let's go look at another one of these. So I'm going to go to number 16. All right, we have a subtraction one here. All right, so I want to take 6 divided by 3b, and I want to subtract from it the rational function b plus 5 divided by 2b squared plus 4b. Now, when you're doing this, it's always a good idea to try to simplify your problem when you can. So I look, and I have 6 over 3b. Well, 6 divided by 3 is 2. So I'm going to write that as 2 divided by b. And then, in order to see the common denominators, because usually it's going to be the product of the two, but it could also be helpful if I factor my problem. So that way I can see, I want to keep my common denominator as small as possible. I don't want to have too much in there. So I have a common factor in the second rational function of 2b. And I have, that would be times b plus 2. And so I want to know, well, what would my common denominator be between these two? Well, the common denominator between these two, if I look, well, I have a b. This function here has a b. But the function over here on the right, it also has a b, but at the same time, it has a 2, and it has b plus 2. So I only have to adjust one of these functions this time, because the common denominator is actually going to be 2 times b plus 2. Only thing I need to do is to take this 2 over b, and I need to multiply it by the parts that it does not have. Well, it does not have, in the denominator, 2 times b plus 2. And so if I needed to multiply that into my denominator, I also have to multiply that into my numerator, so that way my adjustments, it could cancel out and work my way back to my original problem. So 2 times b plus 2 in both the top and the bottom. So now, our next line, we're going to actually multiply out the numerator here. So I need to multiply 2 times 2 plus b times another 2. Well, essentially, the 2 times 2 makes a 4. So I'd have 4 times b plus 4 times 2. So 4b plus 8 divided by, I'm not going to multiply out my denominator, so it'd be 2b times b plus 2. And then I'd have minus b plus 5 over 2b times b plus 2. Well, now we're ready to put these fractions together because they have the same denominators. Now, when I go do this, I have to be very careful because of the subtraction sign. So I'm going to write them together, so they'll have one denominator of 2b times b plus 2. Now, my numerator, I'd start with the numerator of the fraction on the left, so 4b plus 8. And then I go minus. Well, I am subtracting the entire numerator, so I need to put it in parentheses. So minus b plus 5. I have to do that because I'm going to have to distribute that negative to both terms. So I have 4b plus 8 minus b minus 5 over 2b times b plus 2. Now I combine like terms and see what I'm left with. Well, I'd be left with 3b plus 3 divided by 2b times b plus 2. Now, I could factor my numerator and pull out the common factor of 3, but if I did that, I would have 3 times b plus 1, and nothing would cancel. I couldn't reduce the problem any farther, so I'm just going to leave it like this. All right, so that's simplifying, adding, and subtracting rational functions. Now let's look at solving. So I want to solve, and we're going to do 3 of these, but I'm going to do one of these by hand, and then we're going to do the other 2. We're going to solve it by graphic. And so if I was going to work my way through here, number 17, I was going to solve this rational function by hand. What you would do is you would try to create common denominators for every single rational function in the problem. So I'm looking at all of my individual fractions. I have a denominator of x, 4, and 4 times x. Well, the common denominator for all of those functions is going to be 4 times x. So I'm going to multiply each function to create that common denominator. So the first rational function needs to be multiplied by 4 in the bottom, so I got to multiply the numerator by 4. The second rational function, 5/4, it needs to have a times x in the denominator, so if I multiply the bottom by an x, I have to multiply the top by an x. And then I have equals, and then the 1 over 4x already has the denominator of 4x that I need. So now we do the multiplication. So I multiply fractions top times top, bottom times bottom. So I have 4 over 4x minus 5x divided by 4x equals 1 over 4x. Now I don't want to cancel anything out here because it would just take me right back to where I started. I want to now put together the two fractions on the left-hand side because they already have common denominators. When I do that, I have 4 minus 5x divided by 4x equals 1 over 4x. And when we get to this stage, we have a technique that we can use to solve. Because the entire left and right-hand sides both have the same denominator. So the whole left is being divided by 4x, and so is the whole right side. Because that's the case, I can solve this problem by setting the numerators equal to each other because of the equal sign. There's nothing else in the problem. So I could say 4 minus 5x is equal to 1. And then I go solve from there. So I'd have 3 equals 5x. And I divide by 5, and I got x equals 3/5. And I'm done. All right, so to solve rational functions by hand, you create the common denominator everywhere in the problem. Get everything put together on the left and the right-hand side, so that way there's only one fraction. And then set the numerators equal, and then to get your answer. Now, I want to look at number 18. And we're going to solve number 18 by graphing with Desmos. So let me get Desmos here pulled up. Now, if I was going to solve by hand, we would do just like what we did on the other problem. We get common denominators everywhere and set the numerators equal. But no matter what the kind of problem is I'm trying to solve, I can always use the technique of solving by graphing. And I don't like that view. I like this one better. So I'm typing in my two functions here. Now let me get two different colors. And if I'm solving here by graph, so I got y equals the left-hand side. And I have y equals the right-hand side. And instead of a's, I use x's. And I'm looking here, when I'm solving, is I'm looking for any kinds of points of intersections. And so I look here at these graphs and I'm trying to figure out, well, do they actually cross one another or do they not? Well, all initial looks, I don't see them cross each other. I don't see the red and the green intersect one another. So let's try to figure out, well, what does that mean? Well, that should mean, if I don't see any points of intersection, it should mean the answer is no solution. But let's confirm that, because this problem actually isn't too bad to solve by hand. If I look, I already have the first two functions here have the same denominators. And it'd be a real easy adjustment to get this very first rational function to have the same denominator being a squared minus 3a. I would just have to multiply the bottom and the top both by a. And when I do that, I would have a divided by a squared minus 3a minus 2 divided by a squared minus 3a is equal to 5a plus 20 divided by a squared minus 3a. And say, okay, well, we have here, we have common denominators everywhere. Now let's put the two functions together. So I do that, I'd have a minus 2 divided by a squared minus 3a equals 5a plus 20 divided by a squared minus 3a. Well, now because everything has the same denominators, I can set my numerators equal to each other and say, all right, a minus 2 has to equal 5a plus 20. So a minus 2 has to equal 5a minus, or plus 20, excuse me. And I work my way to solve. Well, I would have negative 22 is equal to 4a. And I would divide by 4, and we have negative 11 over 2 is equal to a. Well, that should be an answer. So what is going on? Why didn't we see that? Well, I didn't scroll over far enough to see that. And it's very hard to tell with these sometimes that where do they actually cross, especially when they just wind up bending and getting closer and closer to one another. So I have an intersection point at negative 5.5. So we have to be very careful when we're looking at the graphs, because our initial instinct was to say the answer was no solution when in fact they cross. All right, let's look at one more problem. Oh, something's going on with that thing. Number 20. So let's try to solve number 20 by graphing and see if we get an answer. All right, so we get number 18 off the screen, and we're going to type in y equals the left-hand side and y equals the right-hand side just to see what happens. Okay, so I have my graphs, and let's see what's going on here. Well, this one, I can see very clearly that there are going to be two answers here because I can see the intersections. I have an intersection at negative 2, and I see an intersection at 0.667, which is going to wind up being, I know that Desmos rounds to 3 decimal places. I know that's 2/3.